In this video, I'm going to go over how to balance combustion reactions. So they're generally the most difficult type of balancing that students have to do. So there's a little bit of a trick, a little bit of a different way to do these types of problems. So let's go ahead and, just like with every balancing problem, we need to make a division between the left and the right hand side, and then we need to tally up how many of each element we have on both sides. So looking at the subscripts, we have in the beginning 3 carbons, 6 hydrogens, 2 oxygens on the left-hand side, and we have 1 carbon, 2 hydrogens, and a total of 3 oxygens on the right-hand side. This comes from the 2 from carbon dioxide plus the 1 oxygen we have from water. And so with every type of balancing, it's always a good idea to balance whatever element appears in the most molecules last. So in this case, we can see that carbon appears once on the left-hand side and once on the right-hand side. Hydrogen also appears once on the left-hand side, once on the right-hand side, but oxygen appears 3 times, right? It appears once on the side of the reactants, and it appears here and here on the side of the products. So we're going to go ahead and do oxygen last. So starting with carbon, we can balance out carbon by putting a 3 right here. Instantly cross out carbon and oxygen. These numbers are no longer accurate. Now we have 3 times our implied 1 for carbon, and for oxygen we have 3 times 2 for carbon dioxide, and then we still have this other one right here, so 3 times 2 plus 1. So now we have a total of 7 oxygens. Alright, so now let's go ahead and balance hydrogen. So we need to balance the right hand side to go from 2 to 6, so we do that by putting a 3 right here. Now instantly cross out anything that coefficient affected, so it affected hydrogen and oxygen. So now we have 3 times 2, 6 hydrogens, and for oxygen, we have from carbon dioxide, we still have 3 times 2. And then from the water, we have now 3 times 1. And so this gets us to a total of 9 oxygens. And here's why combustion problems are a little bit more tricky than others, because we now are completely balanced besides carbon and hydrogen. The only thing we have to do is balance our oxygen on our left-hand side. But there's no good option for what to plug in right here, because if we plug in 4, we'll have to multiply by 2 and we'll get 8. And if we plug in 5, we'll multiply by 2 and we'll get 10. And we don't want to have 8 or 10 oxygens, we want to have 9. So here's where the little trick comes in. What you want to do is temporarily answer with a decimal or a half. And we're going to get rid of that in our final answer, but for right now, we're going to say, okay, all we care about is what number can we put in right here that's going to let us have the answer 9. And so the answer is going to be right in between these two answers. So the number right in between 4 and 5 is 4.5 or 4.5. So if we have 4.5, multiplying that by our subscript, we would get to 9. And this is the answer we're looking for. So 4.5 is a valid answer. And then just to fill in the rest of this, we would go ahead and we can leave this blank usually, but I like to put a 1 there just for right now so we can remind ourselves we do have a coefficient in front of our very first molecule, it's just 1. So this is a completely balanced reaction. This would be 9 oxygens, everything else is balanced, but we can't have it be our final answer because we aren't allowed to have half of molecules or any decimals or fractions as coefficients. We can only have integers, we can only have whole numbers in our final answer. So the way we're going to go from this balanced equation, but we have a decimal, to a balanced equation we can give as a final answer is to go ahead and multiply every coefficient by 2. So with that, our answers would be 2, 9, 6, and 6. And these coefficients are the ones that we would put as our final answer. So going ahead and replacing our multiplied by 2 answers as our final coefficients, let's go through and prove that this is completely balanced. So now on the left-hand side, I would have 2 times 3, 6 carbons, 2 times 6, 12 hydrogens, and 9 times 2, 18 oxygens. Now on the right hand side, I'd have 6 times 1, 6 carbons, and 6 times 2, 12 hydrogens, and for oxygens I would have 6 times 2 here, plus 6 times 1 here, which leads me to 18. So now I can see I am completely balanced. I have the same number of each element on both sides. Now let's go ahead and do a couple more practice problems just so you can get more familiar with this technique. So once again, dividing between reactants and products and labeling each element that we have. Having our initial count of each element, I have 3 carbons, 7 plus 1, 8 hydrogens, 1 plus 2, 3 oxygens. On the right-hand side, I just have the single carbon. I have 2 hydrogens, and I have 2 plus 1, 3 oxygens. All right, and once again, balancing the element that appears in the most number of molecules last, which is once again oxygen, which appears in every single molecule. Let's go ahead and just start with carbon. So getting the right-hand side to 3, I need to do this. Now canceling out carbon and oxygen and reevaluating. I now have 3 carbons, and for oxygen I have 3 times 2 plus the 1, so 7 oxygens. Now balancing hydrogens, I need to get the right-hand side to 8, so I need to put a 4 here. So now I have 8 hydrogens, and for oxygen I still have my 3 times 2, plus now 4 times 1, so a total of 10 oxygens. And now I'm back at the hard part of these combustion reactions, because in this case I have this one oxygen that's right here. So I really need all of the oxygens here to add up to 9, because I need to get to a total of 10, and one of them has to come from this molecule C3H7OH. And I'm in my same pickle, because to get the O2s to be 9, if I plug in 4, I'll have 8 oxygens. If I plug in 5, I'll have 10 oxygens, and I really need 9. So once again, I have to have that same thing. I have to use a 0.5 or a 1/2. So if I go ahead and do 4 and 1/2 times 2, that will go ahead and be 9, and that's what I need for this problem. So temporarily, I'm going to go ahead and put a 4.5 here. So now everything is balanced. I'm going to go ahead and put in my 1 here so I can see clearly the math I'm going to have to do. And since I can't leave anything as a decimal, I'm going to go ahead and multiply all of my coefficients times 2. So my final coefficients are 2, 9, 6, and 8. And now just double checking to make sure I'm definitely balanced. For carbon, now I have 2 times 3, 6. For hydrogen, I now have 2 times 7 here, plus 2 times the 1 here. That gets me to 16. And for oxygen, I now have my 2 times 1 here, plus I have 9 times 2. On the right-hand side, for carbon, I have 6 times 1. For hydrogen, I have 8 times 2. And for oxygen, I have 6 times 2. Plus, I have 8 times 1. So this gets me to 20. All right, great. So now I am completely balanced on both sides. Now, one more example. And as usual, step number 1, divide into 2 sides and label what elements we have. And filling in how many of each element I have. And now starting to balance, doing oxygen last. For carbon, I need to put a 6 here, which gives me 6 carbons, and 6 times 2 plus 1, 13 oxygens. Now balancing hydrogen, I need to put a 7 here. That gives me 7 times 2, 14 hydrogens, and for oxygen, 6 times 2 plus 7 times 1, 19 oxygens. All right, and so now we know the drill. We need to find some kind of decimal or fraction that's going to allow us to plug in. In this case, if we do 9, that will give us 18 oxygens. If we do 10, that will give us 20 oxygens. We need to have 19, so we need to go ahead and put in 9.5 to give us 19 oxygens. Now filling in the 1 and multiplying every coefficient by 2 because we can't leave this decimal there, we're going to end up with 2, 19, 12, and 14. And now let's double check our math. So for carbon, 2 times 6, that's 12. For hydrogen, 2 times 14, 28. For oxygen, we have 19 times 2, 38. On the right-hand side, for carbon, we have 12 times 1, 12. For hydrogen, we have 14 times 2, 28. And for oxygen, we have 12 times 2 plus 14 times 1, which gives us 38. So our final answer for coefficients is 2, 19, 12, 14. That's how we balance. Now, just one note, you can balance combustion reactions how you'd balance any other. You can just kind of keep on adding. You could get to this point where you realize, oh, okay, I can't put any number into oxygen, and you can just go higher and higher and higher. You don't have to do it by this 0.5 method and then multiplying, but that is going to save you time if you can become comfortable with this method. Hope this gave you an intro to balancing combustion problems. I thought it was helpful. Happy studying. Hey, I hope you liked that video. Please feel free to subscribe, click around and watch my other tutorials, and as always, happy studying.